Good evening, everyone. My name is David Shuey. I'm the GIS manager at OKI in Cincinnati. OKI is the Metropolitan Planning Organization for Greater Cincinnati. We're the equivalent of MTC here in San Francisco. So any federal dollars that are spent in our region come through our agency to be vetted before they're spent. We're also a partner in the Cincinnati Mobility Labs. Cincinnati Mobility Labs is a partnership between City of Cincinnati, the Chamber of Commerce, OKI, and Uber, which is one of the reasons we have early access to some of this data and some of the stuff I want to show you tonight here. So our region is made up of portions of 3 states, covers 8 counties and about 2.1 million people. We are a federally mandated transportation policy making organization, meaning that we have to exist. And every metro area in the US that's greater than 50,000 people have an agency similar to ours. Federal funding flows for transportation projects and programs through MPOs to local entities for transportation-based projects. And those can be roadways, it can be transit projects, and it can be bike and pedestrian projects. And we measure the effectiveness of our system through performance measures. So we look at safety, mobility and congestion, infrastructure condition, and finally, different transit performance variables. On top of that, we have a travel demand model that we run for the region. And that travel demand model takes a great deal of data in order to run it. The problem with that is a lot of the data that gets fed in this model is not what I would consider current data. So we're looking at socioeconomic data that can be up to 10 years old. We have input from various surveys that are done that, again, can be anywhere between 5 and 15 years old, depending on how often we're able to go out and resurvey the data. So we're always on the lookout for data that's more up to date that we can feed into the model and also look at these performance measures. And so as transportation planners, we often find ourselves in a position where we have a data set that makes us feel an awful lot like this, right? So we have no wheels, we're locked down, and the data is really not taking us anywhere, which is one of the reasons we want to be on the lookout for some of these, what we consider non-traditional data sets. And I'm going to talk about 3 of those here tonight. And so we're going to talk a little bit about the Waze Connected Communities program and how we participate in that and the type of data that gives us and what we can do with that in terms of analysis. We're going to look at ATRI truck GPS data. And finally, we're going to spend a little bit of time on Uber Movement Speeds data set. And before I get into each of these, I want to sort of just forewarn you that not all of these are open and free. Many of these cost money, or there's something where there's a partnership where there's some give and take. And then there's Uber, who has completely opened up their data set. Really great corporate citizen. And again, they didn't pay me to say this, but it's really awesome what they're doing here, honestly. This is very rare to find a private company that's willing to share this kind of data, their internal data that they could actually be probably selling and making money off of. So we certainly applaud them for that. So the first one I want to talk about is the Waze Connected Communities program. And this requires that local communities sign up for this. And in exchange for pushing data to Waze in terms of events that might be happening on roadways or construction projects, things like that, they then in turn return to those communities incidents and congestion data back to the community. So what we do is we're able to take and push up to them all construction projects that happen in our region. And we've gone out and basically automated this process. So any project that we have funding involved with at OKI, we have an idea of what the timeline of the construction is. We take and we grab that from our state funding partners, aggregate it, and we push it up to them on a daily basis. And so as those dates change, we're populating their database with data. And if you're familiar with Waze, well, let me ask you first, how many people use Waze on a regular basis? Okay, we got a couple. So most of the data inside of here is crowdsourced, right? So they're relying on people to push that data up. So if they can get data ahead of time on construction projects and kind of preload that into the system, they're ahead of the game. They're not counting on the crowd to provide that data. So they provide a really nice user interface here for sort of non-technical planners, non-technical GIS folks, where they can go in and look at special events that are happening. So in this example here, we can see that we have some road closures in downtown Cincinnati this past weekend, and that was for Oktoberfest. And so that stuff is pre-populated. In addition, they're going to show accidents They're going to show construction areas like we talked about before, and other things that are going to impact travel flow. Additionally, the user can set up watch lists. So if, for example, you're doing some type of corridor study, and you want to have an idea of what transportation is like in a particular area or congestion, you can go in and flag that area so that it's going to collect that data for you on an ongoing basis. This is great, but we like to see data that's a little more current and stuff that we can kind of control that's not living in the browser. So what we've done is we've gone in and using their API, we actually pull down their data in real time and then populate that into an ATRI geodatabase and can use that to create something like you see here. So this is a current Waze dashboard where we go and look at how many major accidents, how many minor accidents. We list out the accidents here. You can actually click on one of those. It's going to zoom into it. You can learn a little bit about it. We can see how many current traffic jams there are, how many reports of heavy traffic. And then we've also tied into that with some of our traffic cameras in the region so that if our planners want to go in and zoom into a particular area, if something's going on, they'll be able to see that. And as you pan and zoom in and out of this map, what you're going to see happen is the statistics over here are going to change, right? So they kind of update automatically as you zoom in, zoom out, and you kind of get an idea in real time what's going on. This is almost unheard of in our world of transportation planning. Again, we're used to kind of old data. Having this real-time data is something that's very new to us and very exciting. This is an infographic that we were able to create using the Waze data that looks at minutes of delay by segment over time. So the purple line that you see running up and down the map here is I-75, which is a major north-south corridor that runs through Cincinnati. It runs from Michigan down to Miami. And generally it creates a real bottleneck here where it crosses the river. There's a bridge there that's functionally obsolete and needs to be replaced horribly. And there's not been a whole lot of effort to get that done because people are fighting tolls to have that done. Tolls in my neck of the woods are a dirty word. I'm sure in other parts of the country you're used to it, but people don't like them. So we use this to go in and be able to see over time what happens to traffic throughout the day. So you can look at the southbound lanes, you can look at the northbound lanes separately and see where the real bottlenecks are throughout the day. And basically you're going to follow one of these rows over and it corresponds to a segment here on the map. So in whole, you can see throughout the day what happens, but if you want to get in with a little bit more granularity, you can get in and actually see what happens across the day. The next data set I want to talk about and kind of how we're using that is something from the American Transportation Research Institute, or ATRI. And so what we get from ATRI, and this is a data set that we had to purchase, but basically they provide to us GPS breadcrumbs from trucks. And this is not, please? So just GPS points, these random GPS points throughout the day. So trucks all have GPS units in them, and that data is then collected by the provider of the GPS unit. And we don't necessarily get a point every second or every 30 seconds. Each one's kind of random. We get them sometimes, it might be every 10 seconds, sometimes it might be every couple minutes. But we can use that data to do some things, and we'll talk about that here in a second. So what we've purchased from them are basically 8 weeks of data right now from 2016. We've had this data for about 1.5 years or so. We've been working with it. And so it's 2 weeks from every quarter throughout the year. Each record includes a timestamp and a trip ID. And so the trip ID here is kind of critical, right? We're able then to tie those breadcrumbs together to go back and create trips to find out where trucks are traveling. And from what we've been told, these points that we have represent somewhere between 30 and 50% of all truck trips. And so this gets to a bigger problem that we're trying to solve, which is the trucker parking problem. If you're not familiar with the trucking industry at all, within the last couple of years, there's been some new federal mandates. One of those is the electronic logging device, or an ELD mandate. And basically that states that there has to be an electronic log now for trucks. In the past, this was all kept manually. So truck drivers could kind of fudge that, right? If you're out driving someplace and you hit some construction or you hit some traffic and you can't quite get to that next place you want to get, you fudge your book a little bit and hope that you don't get caught. In most cases, they didn't get caught. That's all gone away now. Everything's electronic. So they're held accountable down to the minute. And if they go over on their time, then they end up by risking losing their CDL and serious fines from the feds. The other thing that's led to this is kind of freight growth. Think about Amazon, think about all the way we get packages now and things like that. So freight growth is just over the top. So we've got all these additional trucks that we didn't have years ago. layer into that roadway congestion, a just-in-time economy, and quite honestly, a lack of existing truck parking. And from the research that we've done, there's about 300,000 public spaces available right now out there for over 3 million truckers. And so obviously they're not all stopping at the same time, but it's still, we're far short of what we actually need. And more importantly, what we found is that the spaces don't seem to be in the right locations. Yes, sir. This is nationwide. This is nationwide. That's what we've been told. That's the number that we've been given, yes. So we hear lots of talk in our region, especially around our airport. The airport's at the top of the screen here. You can kind of see it. There's a lot of distribution facilities, a lot of manufacturing facilities in this corridor. And truck parking is a problem. We hear about this anecdotally from the locals, but we really haven't had a way to back it up with data until we got our hands on the ATRI data. So what we did is, this is all done, we're an ATRI shop, this was done in ArcGIS Pro. We went in and with a little Python magic, we're able to go in and find out where trucks parked for more than 1 hour. If they're stopped someplace for less than 1 hour, it could be a drop off, it could be they're filling up for gas, something like that, not a big deal. While this map allows you to see basic trends, it's not real useful in determining density. So the next thing we did is we layered in and said, all right, we want to make sure we're only looking at trucks that are parking in the public right of way. So that was the layer we had. We filtered on that. And then we went back and decided to make a density map of where these truck parking hotspots are. And so we came up with 4 in this corridor, one of which is more concerning than the rest. The bottom one down here, this is an area around several private truck stops. And what we found down there is that we have trucks parking kind of on the right of way waiting to get into these truck stops, or not, the truck stops are full and they can't get in. So again, it's something that needs to be addressed, but it's not as critical as the other one. This one here is actually a rest area. And that's really not a problem as long as they're inside the rest area. How many of you have driven past the rest area at night and found trucks parked back onto the interstate? Those are the ones that we're absolutely worried about. Those are critical because that's, you're out in traffic and someone dozes off or gets a little bit sideways outside that lane. That's really, it's a bad accident. So we're kind of looking at this one to go in and specifically see if we can't pull out how many of those breadcrumbs leave us out on the highway and not actually inside the rest area. This is another hotspot of truck areas. And this one here, when we found it, really caught our eye. We couldn't figure out why it was there. So we did a little bit further analysis. And so the yellow dots down here on the map indicate where trucks are parked on this street called Langley Drive. The airport is just to the east over here. This is an area of a lot of light manufacturing and again, some distribution companies. And within this sort of light industrial park back here, we have a Toyota parts distribution facility. We have a food service company. We have an Amazon warehouse and a couple other things. And so what we did is we took all the trucks that parked back on this right of way back here where they really shouldn't be parked. And they end up by creating hazards for people that are driving down the roads. It's very difficult to get in and out of the driveways because you can't see around the trucks. And had numerous accidents, had other issues with truckers back here that aren't good. So we took that data and said, all right, well, where are the trucks that park here? Where are they going after they park here? And what we found is that 77% go to a facility that's adjacent to the drive here. But we found 23% go someplace else. So we've shared that data with the county. We're going to have a workshop here in October to talk about what we do. And there's some solutions. One is changing your zoning, right? So we have requiring a zoning code that these facilities have more on-site parking for trucks. Pretty easy thing to do, but not something that you can snap your fingers and make a change. That's only going to really affect new businesses. And this area happens to be built out. We're also talking about, with the county, about locating more truck parking. And so what we're going to do is we're going to take all of these areas where we found trucks that go after they park someplace else. We're going to create drive time footprints for each one of those. We're going to overlay them. And then once we overlay all those, we're going to find the best areas to try to locate a new truck parking facility. That's how ATRI data is helping us there. Just kind of a cool visualization. So this is all the trips I told you about, and we've symbolized those with different colors to represent the direction that the truck was driving, and some of them overlay one another, but kind of some cool eye candy there that we created with that, just to give you a way to visualize what the truck traffic looks like. Again, you can see some of these light industrial parks and kind of what's happening back here, just a number of trips that occur. And some of these, quite frankly, rival the interstate. So this is an interstate that runs through here. This is an interstate, but you know, some of these side streets here, very, very heavy traffic. Final use case I want to share with you tonight is movement speeds data set that we did here earlier this year. So to sort of set this up, I want to kind of paint a picture of what this neighborhood is here. It's called Northside. It's one of 52 neighborhoods in Cincinnati. It has a thriving, bustling business district. It's a community up until 20 years ago was in heavy decline. Thankfully, there was enough businesses there and enough people that kind of hung with the place that it's been saved today, and they haven't wrecked everything there. It's a super walkable neighborhood. A lot of hip eateries, a couple breweries, fun place to be. A lot of people, like I said, like to walk. They live someplace, they can walk here to the business district. And what we found is that between 2015 and 2017, we had an above average number of pedestrian and bicycle accidents. And this all kind of culminated late in 2017 when an owner of one of the restaurants here in the business district was killed trying to cross the street in a crosswalk. So that kind of riled up the neighborhood and said, you know what, we've got to do something about this. And Cincinnati's like a lot of other big cities. They have a lot of problems. And it was really the people in this community that kind of rose up and said, we've got to do something about this. So they came together, came up with a list of things that they wanted to try, took them to the city. And one of those things that they wanted to try was a traffic calming project. So this is a major 4-lane road that runs north-south. It connects the northern suburbs with our uptown district where the University of Cincinnati is, with downtown. And basically this is like a highway during rush hour. And previously they had opened this up so there was parking restrictions in the peak periods that didn't allow parking, so it turned it into a 4-lane superhighway. So one of the things they thought they would try is to go ahead and allow parking 24 hours a day. In essence, making this again a 2-lane road. And so what we wanted to do is after they did that, we wanted to use the speeds data to help us analyze the results and what actually happened here. And what I'm showing you here is a map of that corridor with the northbound lanes on the right side, southbound lanes on the left side. And what you see here are the change in PM peak speeds after allowing 24-hour parking. So what we did is we looked at 5 weeks before the pilot went into effect, and then 5 weeks during the pilot. And we basically subtracted the difference in speed and calculated what that change was. And what we found is that throughout the entire corridor, we had a reduction of almost 6% in speeds. We did see some individual segments where we saw increased speeds. We can't necessarily explain why that is, but overall, we saw a decrease in speeds, which was super exciting. And quite frankly, before this data set, we would not have the capability to go in and measure these individual segments. We'd have to go in and create or set up radar counters and grab this data that way, but to get it segment by segment, just couldn't do it. We have some other data sets where we look at larger segments, might be able to look at the corridor as a whole, but didn't have this granularity of the data, which is super exciting for us as urban planners. And so with this data, the city looked at the data and said, you know what, this is a really good thing. They surveyed the community feels safer. Accidents are down by 39% because of this. And we have the data here now to back it up to say it worked. So super exciting. And finally, one last thing, because we like to play with data, right? We like to create different visualizations. We're trying to understand where and when Uber operates and sort of where the concentrations of their activity in the city. And again, so this is our airport over here. This is downtown Cincinnati. This is the uptown area around the city, or around the University of Cincinnati. And the brightness of the lines indicates how many hours during the year the data wasn't redacted. So we know that if there's fewer than 5 trips for a segment in a given hour, data is redacted. If there's more, we have some type of speed measurement there. So we went throughout all the hours of the year and calculated how often the street segment was in use by Uber. And again, in use, we're assuming it's more than 5 Uber trips in an hour. And so then we created a couple graphs here too that show day of the week, and then also show hour of the day to give us an idea of how it's used. Cincinnati is a smaller city than some of the bigger cities where Uber is. And what we found is that our patterns are a little bit different. It's big for trips to the airport, and it's big for nights out at the bar, right? That's how people get home. They get home safe. So that's kind of what we're doing with it. I'll stick around afterwards if anyone wants to talk further about kind of how we're using stuff. But thank you.